inverse trig. Inverse trig is undoing trig to solve for an angle. The way I think about these questions is kind of like Jeopardy. They're the opposite of the questions that we did yesterday. So yesterday, I gave you a trig function, something like sine, and I gave you an angle, something like 45. And your job was to figure out the fraction answer using sohcahtoa. So we would get an answer of 1 over square root of 2. Today, I'm going to give you the category. I'm going to give you the trig name. I'm going to give you the answer, and your job is to give me what was the question. Okay? So same type of problem as yesterday, but we're solving it backwards. Yesterday I gave you the angle and you gave me the fraction. Today I'm going to give you the fraction and you're going to give me the angle. Okay, so it's working back to what was that question. We are going to keep using the same pictures that we've been using for our other problems. So that means we're going to use our two special triangles, 30, 60, 90, and 45, 45, 90. And we're going to use that unit circle. So that means our set of possible answers is actually very limited. We can have answers of 30, 60, those are our angles and our triangles. Or we can have the angles around the circle, 0, 90, 180, 270. And that's it. So there are 7 possible answers to these questions. So we have a very limited set of possible answers. So what we are going to do, when you see this little negative line, that means inverse. So that means the answer to this question is the angle. We did inverse trig on our calculators back when we did law of sines and law of cosines, and we pressed that second button, and this was the symbol that came up on the calculator, was that sine or cosine with the little negative 1 there. So that little negative 1 means the inverse, where our answer should be an angle. The directions also hint that our answer is supposed to be an angle, because it says to give your answer in both radians and degrees, which are ways that we measure angles. So to solve the problem, we're going to think about sohcahtoa. What is sohcahtoa for sine? Opposite over hypotenuse. Then we're going to line up this fraction. So we're looking for an angle that has an opposite of square root of 3 and a hypotenuse of 2. Which triangle has a hypotenuse of 2? The 30, 60, 90 has a hypotenuse of 2. And in that 30, 60, 90, we want the angle that is opposite of the square root of 3, because that's what the top of that fraction says, is that square root of 3 is supposed to be the opposite. So what is opposite of the square root of 3? 60. The 60. So our answer to this question is 60 degrees. That's half of our answer. It says to give the answer in both degrees and radians. So for the second half of the answer, we need to convert this into radians. When we learn about radians, we learn that 180 degrees is equal to pi. So to convert, we're going to think about how many times does this angle go into 180. So how many times does 60 go into 180? 3. So it's a third of 180 or a third of pi, since pi is equal to 180. So we're going to divide our angle into 180, and that becomes the denominator of pi. Okay? If this is somewhat uncomfortable, have no fear. We have many more examples. The next one says cosine. So we begin by thinking about sohcahtoa. What's sohcahtoa for cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Then we line up the fractions. We want it to be adjacent to a 1. What triangle are we talking about now?
45.
Hit the wrong button here. Come on back. All right, so we're talking about a 45, 45, 90 with a hypotenuse of square root of 2. In the 45, 45, 90, you have only one possible answer, because 2 of the angles are 45. The other angle is 90, but you are not allowed to select 90 in a triangle. 90 in a triangle causes problems for sohcahtoa, because 90's opposite is the hypotenuse. And 90 has 2 adjacent perpendicular sides. So 90 is not allowed to come from a triangle as an answer. So if we can narrow it down to the fact that we're thinking about 45, 45, 90, we only have one possible answer, 45. How many times does 45 go into 180? 4 times. It's half of 90, so it goes into 180 4 times, and that's our denominator then. The next one says inverse tangent of 1. Well, when we think about SOHCAHTOA, we need to think about a fraction. So we can make anything into a fraction by just dividing by 1. And then what is SOHCAHTOA for tangent? Opposite over adjacent for tangent. TOA, T-O-A. So I need to be opposite of a 1 and next to a 1. So a triangle that has 2 ones on it, not the hypotenuse. Tangent doesn't care about hypotenuse, but the other 2 sides, opposite and adjacent, are both 1 with a 45. And we said in the last question that goes into 180 4 times. Sine. What's SOHCAHTOA for sine? Opposite over hypotenuse. Line it up. We want to be opposite over 1. That could be either triangle. We want a hypotenuse of 2, so that narrows it down now. Which triangle are we talking about? 30, 60, 90 has the hypotenuse of 2. And we want to be opposite of 1, says the top of that fraction. So what's across from the 1?
30.
The 30. So our answer is 30, which goes into 180 how many times? 6. So our denominator is 6.
Wait, is that the sign?
The pi over 6?
Oh.
That's our radian measure. So we're converting the degrees into the radians. SOHCAHTOA for cosine. What's SOHCAHTOA for cosine? Adjacent over hypotenuse. So I'm going to be next to a square root of 3 with a hypotenuse of 2. So which triangle are we talking about? 30, 60, 90. So clearly having these memorized will be helpful to you. Hypotenuse of 2, and I want to be adjacent to the square root of 3. Adjacent means right next to. So what angle is right next to that square root of 3? The 30. Which we said goes into 180 6 times.
That's really it.
Square root of 3 is not a fraction. When we think about SOHCAHTOA, we like to think about fractions. So what do we do? Put it over 1. Then what is SOHCAHTOA for tangent? Opposite over adjacent. We line up the fraction, so I'm going to be opposite of the square root of 3 and next to a 1. So which triangle are we talking about? 30, 60, 90. If I want to be opposite of the square root of 3 and right next to a 1, what angle is that pointing to?
The 60.
The 60, which goes into 180 3 times. All right, sounds like you're starting to feel pretty comfortable with it, so I'm actually going to change it up a little on the next question. So, this is not a fraction, so what do we do? Put it over 1. What's SOHCAHTOA for sine? Opposite over hypotenuse. So I want to be opposite over 1. That could be either triangle. I want a hypotenuse of 1. Which triangle has a hypotenuse of 1?
45. None of them.
No, the 30. It's
Neither one have a hypotenuse of 1. In the 30, 60, 90, the hypotenuse is 2. And in the 45, 45, 90, the hypotenuse is square root of 2. So we don't have a hypotenuse of 1. That means our angle isn't going to happen in a triangle. So there's where we labeled our points around the axes, and we labeled our angles, counting around our 90s. And we said that the circle has a radius of 1. So we could label our points coming around. The point on the 0 line would be over 1 or 0. The point on the 90 line would be over 0 or 1. 180 line, negative 1, 0. And 270 line, 0, negative 1. Now how do those points help us find trig stuff? What do those points represent?
Cosine and sine.
Cosine and sine, and we'll talk about it. That cosine comes first, and then sine. So in this question, it says that the sine is supposed to be 1. So that means sine is going to be the second part of the point. 1 is the second part of the point. I don't know what the first part is, but it doesn't matter. I'm going to find the point around the circle that has the second number as being 1. So where does it happen?
90.
Up at 90. So our answer is 90. How many times does 90 go into 180? 2. So my first strategy is to always try to look for a triangle. But if you end up needing a hypotenuse of 1, that doesn't happen. There's not a hypotenuse of 1. So then I resort to going to the circle. The next question is a negative value.